This is part 2 of section 1.1, analyzing categorical data. This is AP Statistics, and I am Todd Thedell. So we are going to start at the two-way tables. Take a look at page 11 of your textbook, and that's where two-way tables of margin distribution start. When data involves two categorical variables, we begin by examining the counts or percents in various categories for one of the variables. So we get what's called a two-way table. This describes two categorical variables rather than just one, organizing counts according to row variable and a column variable. So we have this situation about a survey of 4,826 people. I'm looking at page 12 now of your book, where it's called I'm Gonna Be Rich. They were polled and asked you, what are your chances, what chances you have by middle class income of 30, at the age of 30. So the table shows us lots of things. We have young adults by gender, so we have female and male who were polled about getting rich and whether they thought they'd be rich. And we have the variables or the values of almost no chance, some chance, but probably not, 50-50 chance, a good chance, and almost certain. So the first question is, what are the variables described by this two-way table? Well, the variables are gender, so we have male or female, and we have opinion. That would be the opinion for these categories. How many young adults were surveyed? The total, of course, is 4,826, and that was from 2,367 female and 2,459 male. So you should be able to look at a two-way table and get this information from it. All right, so the information of one of the categorical variables in a two-way table counts in the distribution of values of that variable among all instruments in the table. So what does that mean? The marginal distribution will be how the margins are distributed. So we use the data in the table to calculate the marginal distribution in percents for the rows and the columns, and then we're going to make a graph of it. So let's go ahead and do that. Here is the data again, and so we're going to examine the marginal distribution of chance. So we have the totals here, but these are the counts, and what we want to do is we want to get a percentage. So we produce a data table similar to this, or I suppose you could just put another column out on the right of that and calculate the percents there. So to get the percent of almost no chance, we have to take the total, 194, and we divide it by the total surveyed. So we're not looking at both. I mean, we're looking at both at the same time now. We're just looking at one of the variables, and that's the opinion. So go ahead and calculate the rest of this table. You should pause the video to do that. Okay, so to calculate the rest, you should check your work now. So some chance comes out to 14.8%. 50-50 chance, 1,000, or the 1416 divided by the total is 29.3%. 29.4% for a good chance, and almost certain will be 22.4%. Okay, so now that we have those percentages, we are going to produce a bar graph. So we want to take the categories and put them along the bottom, and then percents going up, because the percents depend upon the category, right? And then go ahead and make that data table. Pause the video. Okay, so welcome back. So you should have something that looks like this. And so the 4% is small, 14.8. The 229s are pretty close to each other, and then 22.4. So that gives us a better way of looking at it, on which one it was. We'll take a look at a little bit more of this data in a bit. Let's try, turn to page 22 of your book, and we're going to look at exercise 19 as an example. So this scenario has to do with whether people, whether they buy recycled filters, coffee filters, and what their opinion on the quality of recycled materials are. So the data is shown. We have these variables. So what variables do we have? We have the variable, do you buy recycled products? And the answer to that is yes or no. And the other variable is what do you think the quality is? So quality as well as whether they buy or not. Those are the two variables. How many people does this table describe? So this table is incomplete for us. It doesn't have the margin data for us. So let's go ahead and you figure that out. You should have got 133 if you add up all those numbers, because each one of these numbers in the middle represent the one of the people who were polled. Okay, so how many of these were buyers of coffee filters? Pause. Okay, so you should have got 36 from that, because we have a total. We're just looking at the yes column represents the people who did buy recycled products. So that's a total of 36. Give the marginal distribution in percents of the opinion about the quality. Okay, so now we're going to look at this at different order than that's asking. But if we want to calculate what the percentage is of people that bought recycled filters, then we take the 36 divided by the 133, and then we add these up. We get 97. From that calculation, we can get 72.9%. 97 divided by 133, or if you're sure about this one, you could take 100% minus 27.1, and that would give you the 72.9. Now, if we do the percentage of the quality, go ahead and pause the video and calculate this column in percents. Okay, so that you should have got 49 total, 20 and 29, and then we're still dividing by 133 because that's how many were polled. And so each one of these, 24% and 39.1%. So that represents, that's the marginal data, marginal distribution in percents. We're not going to do anything with those right now, but you could then make a chart out of it. You could either make a pie chart out of the quality, you could make a pie chart out of the recycled, or you could make bar graphs out of either one of those. So now we're going to look at the relationship between categorical variables. So now that we were able to calculate percentages of these, we're going to look at how something that's called a conditional distribution. So a conditional distribution of a variable describes the values of that variable among the individuals who have a specific value of another variable. So to do that, we are going to select the row of column that we're interested in. We're going to use the data in the table to calculate the conditional distribution in percents of the row and the column. And then we're going to display it this time in a graph. And two different graphs will be, one will be a side-by-side bar graph, and the other will be a segmented bar graph. We're going to use those to compare the conditional distributions. Okay, so we're going to take that am I going to be rich data, and we're going to calculate the conditional distribution of opinion, and we're going to look at the males first, and then we're going to examine the relationship between gender and opinion. So first, let's calculate the percentage of males. So to calculate almost no chance from the males, we can see that we have 98 males responded, but that's going to be out of the 2,459, because that's the total number of males that responded. So that's only 4%. Don't divide by the total people, because we're only looking at one of the things. That's why it's called conditional distribution. Is we're just the condition is the male gender, their opinion towards whether they're going to get rich or not. So go ahead and pause and calculate the rest of that table. Okay, you should have got 11.6%, 29.3%, 30.8%, and 24.3%. I did not calculate the total on that to see if there's any sort of round off error. Perhaps that's something we could have, should have, would have done. Okay, so now we know that's a conditional distribution of the opinions of males. Now we're going to examine the relationship between genders. So what we have to do is we have to do the same thing for the females. So go ahead and pause the video and do that. All right, so you should have got 4.1%, 18%, 29.4%, 28.80%, and 20.5%. Okay, so now in order to show this data, to display it, and to answer our question, we're going to examine the relationship, see if there isn't a relationship between genders, and we're going to make a bar graph. So we set that up with percentages, of course, going up, and then we're going to have the males and females, and we're going to do what's called as a segmented bar graph for this one. So to do that, we take each of the percentages from the columns and we stack them, stack the percentages, so that from the bottom to the top, of course, it represents 100%, or nearly anyway, maybe a round off error. And so then we did the same thing with females. Now, what advantage is this to anything else? Remember, our eyes look at areas, so you can sort of see that the bottom one, the almost no chance, they're about the same. And sure enough, they're only 1.1% difference. And then the some chance, you can see that the female, the area of that is larger than that one, and sure enough, you can see that the numbers. So, and that gets a little bit more difficult because you have to sort of estimate, but you can see they're about the same. It looks like the males are a little bit more on that one, and then males a little bit more on that one too. So this just gives you a different way of looking at the data. So what we're doing is we're examining whether there's a relationship between gender. So can we say that there's an association between gender and opinion in the population of young adults? Maybe, I don't know. It could be. Making this determination requires formal inference, which we have to wait for a couple of chapters on that. So I would say at this point we could say, yeah, maybe so. It looks like most of the males think, higher. If we were to take and do a side-by-side graph, we might see that most of the top categories, the males are above than the females. So that means they have a positive opinion on whether they are going to be rich. Yeah. Okay. So, but be careful. Even a strong association between two categorical variables can be influenced by other variables lurking in the background. That's a term that will be come across periodically. That's kind of fun to talk about. But there could be all kinds of other things. We don't know where this poll was taken. Could have been taken at a male-dominated school or whatever. We don't know exactly any of the details. But we're going to take a look at that in later chapters. Okay, so you should know how to display the summary of both parts of the chapter is displaying categorical data in a bar graph. Should be able to do that. Should be able to identify what makes graphs of categorical data deceptive. Calculate and display marginal distribution of categorical variable from a two-way table. Calculate and display the conditional distribution of the categorical variable from a two-way table. So just be careful, you're only including those in the condition. And then describe whether there's an association between categorical variables. Here are some problems assigned, so you can do those, and I'll check those in class. Okay, if you have any questions or anything like that, you can get a hold of me through Schoology or email me or ask me in class. Okay, thanks for watching.